Good afternoon, space fans. Today I'm going to be taking you over the COCO plot or co-orbital coplanar plot, which naturally follows on from the GEO neighborhood from yesterday. Whilst at GEO, we can just look at distances between objects and get a good idea of who's around us because things happen very slowly at GEO. You can see I just brought up a quick plot here as we propagate things out. Select the Intelsat to keep us moving around a lot. But you can see we're traveling at 7.6 kilometers at LEO and only 3 kilometers here at GEO. So things happen very slowly at GEO. If someone's coming for you, you're going to get some warning, you're going to get some notice. At LEO, that is not the case. An orbit period every 90 minutes, more or less. You can be on one side of the Earth and catch up to someone else on the other side after an orbit period. So things happen very, very quickly at LEO, and that's not the case at GEO. So while we get away with just using distance at GEO, at LEO, we're more concerned with everybody that's in plane with us, and so coplanar, but also that are close by, so co-orbital. So we're going to analyze this using Space UI again. So jumping across there, proceed as guest. This time we're going to be using the COCO plus trick plot, and I'm just going to punch in a satellite here, 47967. And what this will do is inject that satellite into the COCO and trick plot. It's 47967, probably getting out 3 days. We'll just select a satellite here. And we can see we're not finding anything, so there's nothing coplanar co-orbital with us. If we bump up this distance, though, to say 1,000 kilometers from 500, we find something, M2B. And this 47967 is actually M2A, so these are a pair of satellites that are flying in formation. So as you can see there, they are co-orbital. Maybe not coplanar because they're about 700 kilometers apart on but you can see all of their other orbital elements match quite closely in terms of inclination, right ascension of the ascending node, and their semi-major axis. So just like in the GEO neighborhood, if there's multiple items that are found in the COCO, they'll be listed out here on the bar graph. And the different aspect here on the COCO plot is this four-way spider graph. So it shows the inclination difference, the distance, the right ascension of the ascending node, and the semi-major axis difference. So you can see they're matched in these three elements, inclination, semi-major axis, and RAN. You see the distance is way out here. So that tells me, yep, they're coplanar, but one is far more around its orbit in true anomaly than the other to give it this distance offset. Just like with the GEO neighborhood, we can plot this in Space Cockpit. So whatever you put into the bar up there and whatever COCOs it finds, it's going to drop them into Space Cockpit for you automatically. I'll just switch to political map. It's a bit easier to see here. In LEO. One thing to keep in mind, you might want to switch to RI, which fixes the coordinate reference frame. It's quite useful when you're looking at things that are coplanar co-orbital. And here we can do things like, let's for example say we did a maneuver on M2A. We can just do a V-bar hop here of 50 meters per second. And you can see that if we bring up a relative orbit, quite useful for visualizing relative motion between satellites and things in this RI reference frame. So that's the COCO plot. Find everyone that's coplanar co-orbital. Attached to the COCO plot, if you scroll further down in Space UI, you can see we've done this plus trick. So now if we enter 47967 and 47973, I think it was, selected the first TLE, second TLE, and it will run automatically for us. This is the time radial in-track cross-track plot. So you can see, just like in Space Cockpit, they're offset in their, let's just fix it on here. So they've got a radial offset, in-track offset, and their cross-track is just oscillating up and down. The absolute distance is getting greater over time, as you can see here. So they are separating. So they must have some small semi-major axis difference between them. The radial separation, this looks like it's decreasing, but it's actually increasing because this is negative. So we're going from a smaller negative to a larger negative. So they're actually separating radially. The in-track separation is definitely accounting for most of this absolute distance, though. So that is the COCO plot combined with a time radial in-track cross-track plot. Very useful for analyzing LEO satellites, finding things that are coplanar co-orbital with you, and then being able to use Space Cockpit to continue the analysis. I hope everyone has a great Thanksgiving and happy hunting.